Hi, and welcome to video 101 of chemistry. Today, I will be teaching you how to classify properties of matter. By the end of this video, you should be able to define matter and classify it as either an element, compound, or mixture. Furthermore, you should be able to classify mixtures as heterogeneous or homogeneous. So what is matter? Well, matter is anything that has mass or takes up space. In fact, matter comes from the Latin word materia, which just means stuff. Some examples of matter include solid, liquid, and gases. I include gases in this because a lot of people forget that you can actually measure out the matter of a gas by simply condensing it and place it inside of a balloon. By doing so, you can then calculate the density of that gas itself, because remember, density is simply mass divided by volume. Remember, you are living, you occupy space, and you have mass. Therefore, you matter. So, is everything matter then? Well, not exactly. For instance, light from a torch and heat from a fire are just some examples of things that do not have matter. So let's talk about pure substances now. A pure substance is simply an element and a compound. So what is a substance? Well, a substance is a type of matter that has uniform and definite composition no matter what. What I mean by this is, let's just say that I take some salt from New York and I compare that salt sample to that of Texas. Well, what I find out is that the salt from New York and Texas has exactly the same composition. Alright, so let's look at elements. Elements are the most simplest form of matter, which cannot be broken down chemically into a distinguishable form. And I highlighted the word distinguishable because a lot of people assume, well, elements can be broken down. They're subatomic particles that are protons, electrons, and neutrons. But when you look at a proton, for example, you need to understand that when you compare one proton from something to that of something else, you can no longer make out what that substance is. Therefore, elements are the smallest particles that we can still determine that this is in fact this as opposed to something else. Now, you can find elements on the periodic table, and what's interesting about elements is that, well, the first letter must always be capitalized. The second letter should be lowercase. In the cases that there's just one letter, well, that letter must be capitalized as well. So let's continue looking at elements. Well, there are 7 diatomic elements. This just means that elements are bonded to itself, and they're found naturally like that in nature. For instance, we have hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine. Right? Wow, that's a lot. Now, an easy way to remember this is, well, have no fear of ice cold beer. Alright? That just means that every time you see hydrogen, it's H2. Nitrogen is N2. Fluorine is F2. I think you get the idea. So, remember, this is how you will find these elements naturally in life. Alright, let's move on to compounds. Well, compounds are actually made up of 2 or more elements that are chemically combined in a fixed ratio. Most matter in this universe is in the form of compounds. Some examples include, well, H2, which is just hydrogen gas. When you combine hydrogen gas with oxygen gas, well, you've guessed it, you produce H2O, which is just water. Another example of this is, well, sodium, Na, plus chlorine, which produces, well, table salt. Alright, let's go ahead and take some time to practice. Now, let's look at iron. Well, I can find iron on the periodic table. Therefore, it should just be, well, an element. Copper, on the other hand, is also on the periodic table, so it is just an element as well. Hydrogen, H2, even though it's 2 hydrogens combined together, well, this is a diatomic element, so this will also be an example of a element. Water, H2O, yes, hydrogen is on the periodic table and oxygen is also on the periodic table, but now I'm seeing a combination of 2 or more elements being put together. Therefore, this must be a compound. We also have sugar. Sugar is C6H12O6. Well, there's more than one element here, so this is just a compound. Oxygen, which is really just O2, is also an element. Salt, which is NaCl, would be an example of a compound. Lastly, we have calcium. Calcium, if I looked at the periodic table, I'd see that, well, it's found on the periodic table, therefore it's just a element. Alright, mixtures. A mixture is comprised of two or more substances that can vary from each other. For instance, one cake of chocolate may not be the exact same as another. Alright, let me break that down. If you see this picture right here and you look at a heterogeneous mixtures, well, the heterogeneous mixtures you can see are kind of just varying throughout. There's not one specific trend. And if you compare that to the homogeneous mixture side, you can see that there's a clear pattern. Those molecules have actually unified themselves in a pattern throughout. Therefore, I can distinguish the two just by looking at it like that. But just to include some examples to make sure that you really get this, when first talking about homogeneous mixtures, it's important to know that they can form a solution. This just means that you take a solvent, such as water, and you pour some sugar in there, which are your solutes, the smaller particles of things, and you stir it all together. This new thing creates a solution. And when I mean solution is, I'm saying something that is uniform throughout, where you can no longer tell that they're two separate things. So if you look at the next example over here, we have milk. Now, milk is also considered a solution in this case because of the fact that if you know anything about milk, normally you have that fat that's on the top, and then you have all the vitamins and minerals that are floating on the bottom. But when you mix it all together, you form this one substance, and it looks like one clear liquid white thing, and because of that, we in fact call it a homogeneous milk. In fact, if you look at some of the labels, you'll see that it's called homogeneous milk. Now, let's move on to heterogeneous mixtures. Heterogeneous mixtures are not uniform throughout. In fact, you can see parts that are different from each other. So when we look at those M&Ms over here, I see that there's green, yellow, orange. Well, if I put my hand in there and I started to pluck them, I could actually remove all the green, all the blues, and I can form different piles. Because of this is just a heterogeneous mixture. Now we have some mixed nuts over here, and I can do the same thing with the mixed nuts. I can pull them all apart and you would clearly get a heterogeneous mixture. Lastly, we have some more milk, but this time we can see that separation. We see the fat on top, we see the milk on the bottom. So this would be an example of a heterogeneous mixture. Alright, hopefully you're seeing the trends. Just here's another trend looking at it from the molecular perspective. Notice here in the homogeneous mixture side, it's uniform throughout. And the heterogeneous mixtures, well, it kind of seems like it has a pattern, but not really because we see it being broken a couple of times. So this is a clear indication that this is a heterogeneous mixture. All right, now it's your turn. I want you to tell me. Here we have a mixed salad. Hopefully you've guessed that this is a heterogeneous mixture. Next, we have some mixed nuts. And because we can separate these, well, this is just heterogeneous. Now we have paint. This paint seems to be uniform and unified throughout. Because of this, it is going to be homogeneous. Lastly, we have some honey. Now, when I look at the honey, as I look at it, I can't really distinguish it from any other particles. Therefore, I can conclude that this is just a homogeneous mixture. All right, it's time to practice. Let's identify the difference between element, compounds, and mixtures. Ready? Here we go. Well, chlorine is on the periodic table, so it is simply an element. Air, well, it's not on the periodic table, so I can pretty much assume that is a mixture. Water, tap water. Tap water is interesting because if I compare my tap water from Texas versus that of someone else, let's say in Wyoming, I can pretty much guarantee you that our water would not look the same or even taste the same. For that matter, we can conclude that water from the tap would be an example of a mixture. Purified water, on the other hand, well, this is what you're used to seeing in chemistry. It's H2O. This means for every 2 hydrogens, you have 1 oxygen. Because of this, because of that fixed ratio, this is just an example of being a compound. Now we have gold. Gold is on the periodic table, so it's an element. Methane, that's just another way of saying gas. Well, methane gas, that is. So this is This is demonstrated by the formula CH4. Well, I can clearly see that there's two elements being put together, so this would be a compound. Sand, that is a mixture. Pepper is another mixture. Now we have iced tea. This is just sugar mixed with water. So this would just be a mixture. Steel, if I look on the periodic table, you notice that steel is not up there. So this is a mixture. Chlorine, this would be an example of an element. By the way, chlorine is symbolized by Cl2. It's one of those diatomic elements I talked about earlier. Blood is pretty interesting. We can have a debate later on whether this is considered homogeneous or heterogeneous. But for now, let's just say that it's a mixture. Soap, well, that's also a mixture. Brass would also be considered a mixture. Lastly, we got sodium. Sodium is just Na, so I can look in the periodic table and find that. Therefore, I can conclude it is an element. All right, so remember, mixtures have two parts to it. The first part is a solute. This is a substance that is being dissolved. The second part is the solvent. The solvent is what is being used to dissolve the solute. Now, another way that you can hopefully memorize this as well, the solute is a smaller word than solvent. Because of this, we know that the solute are the smaller particles. You can form a solution when you dissolve the solute into the solvent. Here's an example of that. Here, we're taking it looks like we're taking some particle and dropping it in a solution of water. Then those particles begin to disperse throughout. So you can see here that they disperse, they form a homogeneous mixture there. So guys, remember the rule of thumb. If you see a single symbol with a capital letter, it is probably going to be an element. If there are two or more combined symbols with two or more capital letters, that's probably going to be a compound. All elements and compounds are homogeneous because everywhere you go, they look the same. If it doesn't have a fixed ratio or chemical formula, then it can be either a homogeneous or heterogeneous mixtures. Lastly, I like to end on a fun note. So here's a fun fact. Did you know that there are 6 elements that make up 99% of Earth's atmosphere? Now, if you're wondering what those 6 are, well, that's simply carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. How did I know that off my head? Simple. CHOMPS. CHONPS. Thank you. And I look forward to seeing you guys in video 1-2. Have a great day.